Hello, let's solve this question. Find the free fall time of an object of mass m from a height 2r to r. So let's solve. Here, given here it is. Let's assume this as surface of the earth, right? I mean, from here, the object is initially, which is mass m, which is at a distance of 2r, and what will be the time it takes to reach an height of r, right? So let's start. The gravitational force between Earth and this body of mass m will be G, capital M by x square, which is equal to net force acting on a body is equal to mass times of acceleration. Then this m will go off. Then Gm by x square is A. Fine. A can be written as dv by dt, which can be written as dv by dx into dx by dt, which is this dx by dt is velocity and dv by dx, right? After a certain time, I mean, you can assume it's after an arbitrary time t, it will travel a certain distance and reaches, this guy reaches certain height x, right, from the surface. So as you can see, as the potential energy decreases, kinetic energy increases. That means dv is positive, but dx is getting decreased. So this will be negative. So gm by x square is minus v dv by dx. Fine. Now you can do gm by x square dx equal to minus v dv. Let's try to integrate this. Fine. Now we are integrating from its 2r after an arbitrary distance x from surface of the earth, right? Then from initially it has velocity of 0 and it reaches a velocity v at height x. So let's try to solve this. As gm is constant, keep it out of the integral. 1 by x square is x power minus 2 plus 1, right? It will be minus 1 by x, and integral limits are 2r into x, which is equal to minus v square by 2. Fine. Then this is, you can minus gm into 1 by x minus 1 by 2r equal to minus v square by 2. This minus will get cancelled, and you can see this gm into, you can multiply 2 here, right, on both sides. Then this will be 2 by x minus 1 by r, which is equal to v square. Fine. That is v equal to root gm into root of, as we can do some simplification here, this will be 2r minus x by xr, right? So let's proceed further. As you know, this dv can be written as dx by dt. Fine. As you can see, dt will be positive, right, because time proceeds further. I mean, from 0 to, if you can say, it starts from 0 and after an arbitrary time it gets increases, but dx is getting decreased. So you can make a minus symbol here, right? Then this is minus dx by dt is root gm by r, right, into 2r minus x by x. Fine. Then this will be root gm by r into dt equal to root of x by 2r minus x into dx, which is minus. Let's try to integrate. Right? We are integrating from 2r to r. Right? We need to figure out the time from 2r to r. So this will be, sorry, this case will be, this case will be at time t equal to 0 to tf, right? Those are the limits for x case, 2r to r. So finally, this will be root gm by r into tf equal to minus integral 2r to r root of x by 2r minus x into dx. So you cannot solve this directly. So let's make some substitutions here. As you can see here, there is a 2r minus x in the denominator. So it's very obvious to take x equal to 2r times of sine theta or cos theta. So let's consider here x equal to 2r into sine square theta, right? Then dx is 2r into 2 sine theta cos theta, right? Then this will be 4r sine theta cos theta d theta. Fine. That is, now let's make some simplifications here. Here this case will be root of gm by r tf into minus of integral 2r to r. I mean, we are not changing the integrals here because I mean after getting the simplifications, you will change it into the x coordinates and substitute the r values, right? So let's proceed. Then this is x, here it is 2r sine squared theta by 2r minus x is 2r minus 2r sine squared theta. 2r will get common, then 2r into 1 minus sine squared theta, which is cos squared theta. Then this is 2r cos squared theta. Then dx is 4r sine theta cos theta into d theta. This 2r will get cancelled and this will be minus, right, integral 2r to r sine squared theta by cos squared theta, which will, I mean, it's a root, right? Then you are left with sine theta by cos theta into 4r sine theta cos theta d theta. Cos theta will get cancelled. So then next, let's take 2r is common. I mean, let's keep it out of the integral. Minus 2r to r. Then this will be, if there is gone 2r, then this will be 2 sine squared theta. Right? Which can be written as minus 2r into integral 2r to r. 2 sine squared theta can be written as 1 minus cos 2 theta d theta. Right? Which is minus 2r into integral d theta is theta minus sine 2 theta by 2. Fine. Then these integration limits are 2r to r. Right? As now we need to do this. Here we have substituted x equal to 2r sine square theta, right? Here we have substituted x equal to 2r sine square theta. That implies sine square theta is x by 2r. Then sine theta, Sin theta is root of x by 2r, then theta is sin inverse of root x by 2r. So this is minus 2r into, this is a simplification, fine, minus 2r into theta is sin inverse root of x by 2r minus 1 by 2 into sin 2 theta, right? Sin 2 theta can be written as 2 sin theta cos theta, right? This can be written as, just write it down, sin theta is right. Then sin 2 theta can be written as 2 sin theta into cos theta. Cos theta will be root of 1 minus sin square theta, which is x by 2r, fine. So this will be half into, this case, half into sin 2 theta, right, which is 2 into sin theta root x by 2r into cos theta is root of 1 minus x by 2r, and integration limits are 2r to r. 2 will get cancelled, that is minus 2r into sin inverse root of x by 2r into 2r r minus of root of x by 2r into root of 1 minus x by 2r. I'm just separating these two things, right? So for this case, let's proceed. This is minus 2r into, when x equal to r, this will be sin inverse of 1 by root 2, which is pi by 4, fine. Then when x equal to 2r, 2r will get cancelled and it will be sin root of 1, which is sin 1, then which is pi by 2 minus pi by 2. For this case, when x equal to minus of, right, when x equal to r, this is when x equal to r, this case, first case, when x equal to r will get cancelled, this will be 1 by root 2, and this part, when x equal to r will get cancelled, 1 by root 2, fine. And what about x equal to 2r? When x equal to 2r, this case will get 1, then 1 minus 1 0, so this will not contribute. So we are left with minus 2r into, this is pi by 4 minus pi by 2 minus half, right, which is minus r into pi by 2 minus pi minus 1, right? This is pi by 2 minus pi is minus pi by 2 minus pi by 2 minus 1 minus r into minus pi by 2 minus 1, which is r into pi by 2 plus 1. So finally, root of gm by r tf is r into pi by 2 plus 1. So finally, tf is pi by 2 plus 1, right? Pi by 2 plus 1 into r into root r by g. Or else you can write more simplified version as more compact form. Pi by 2 plus 1 into this r, we can take it inside, which will be r square. Then this is r cube by gm. So our final solution is tf is pi by 2 plus 1 into root of r cube by gm. This is the solution.